What we have back here on the screen, and this is a live demo, this is all live feeds from the sensors and instrumentation we have on the ground. Up here on the left is our Sapphire display from AX Enterprises, where they're integrating all the live sensors at Griffiss onto one nice common operating picture. And the scenario that we're going to go through here is basically we have a general aviation aircraft. This is its flight pattern here. You see the blue. And this is live tracking data right now. So the yellow circle you see up here, that's cooperative ADS-B data. That's that aircraft transponding out, here I am, here I am. The very unique capability we have at the airport here is this pink circle. That's the R1400 radar, which you see over here, which several have been deployed here around the airport already. That can detect very small drones around airports. Traditional FAA systems around airports today, they're not designed to detect and track small drones. They're designed to see large planes at high altitudes. You know, from the movies, you always hear like, oh, he's flying under the radar, he's below the deck. Typically these low, slow-flying drones, traditional air traffic radars just aren't designed to see them. What we have down here in this scenario is there's going to be a drone over in this area that's going to pop up unannounced. Basically, this plane coming in on approach is not going to know about this traffic here. Okay, look, I think we just went live here with that drone going up in the air, and you could see that detection happening there with the radar. These strobes that you see on the screen here as well, that's another unique capability that's been deployed around this airport. It's called direction finding or RF detection. These sensors are picking up the communication downlinks coming off of that craft. So we have basically two sensors right now that are detecting this drone that's not supposed to be around an airport. And I think something that's really of importance to the audience and group here, this is live data tracking a drone around an airport right now. I don't believe this capability exists at any other airport in the world. So we can see our general aviation aircraft. He's coming in upon final approach. He's planning to land here at the airport. And what we have over here, I'm sorry I didn't really talk about this display yet. I'm so excited about what we have capability-wise here at Griffiss. This is going to be what would be traditionally seen in the FAA tower, or the type of data that they would have displayed. Once again, you don't see any of this non-cooperative data from the drone down here. We're just seeing the track coming in for the plane. So we're coming in on final approach. With the instrumentation that we have here to detect and track this drone, this is the type of call that would come in from the tower. It would basically be 32 Juliet, Griffiss Tower, unidentified traffic, you're 12 o'clock, 1 mile, recommend right turn to the west. So based on that world-leading unique air picture we have here, the tower would be able to radio in that command to this pilot who's planning to land at the airport right now and avert a potential catastrophic collision with an unknown pop-up drone within its approach path. Now we can see the call. It was a great call from the tower. You could see him coming off here, and that's a basic scenario for how you could use this data in the situation room. And you can think of a bunch of other scenarios here, whether it's critical infrastructure protection around nuclear power plants, government facilities, prisons, but the ability to detect these very hard to see non-cooperative drones is a leading capability we have here in the region. And with the investment from the governor in partnership with Oneida County to have this deployed at this airport and to be able to test and validate here, once again, a world-leading capability here that we just saw a live demonstration of.